Okay, boys and girls, welcome to Unit 3. This is Unit 3 Statistics. What we are going to begin with, and throughout this chapter, this is all about different types of averages. And so scrolling through this first assignment, what I'm implying is that there are the big three. There's the mean, median, and mode. And a quick explanation of what these things are is this. How I remember these things. It's mean. So, it's mean. Oh, mean. It's mean of me to ask you to find the mean. Okay, it's really mean. Why is it so mean? Well, you have to do the most work, of course. What it means to find the mean is you have to add up all of the numbers. Oh my gosh. Have to add up all of them? Yeah. And then you divide. Divide. We divide by the number of them. Okay? Number of numbers. Okay? In more kind of math speak, kind of like in statistical speak, what this is, to add something all up, that is also known as the sum. Okay, so I add up all of the numbers, so we'll call them x. We add up all of the numbers, we add up all of x, and we divide by the number of them. That is also known as the frequency. Okay, it's the frequency, or it'll be denoted by the letter n for the number of some things. Okay. So you add them all up, and you divide by the number of them. That is the mean. Okay, I'm going to jump down to the mode. And the mode is the one that happens the most. All right? It's the number that happens the most. Now, speaking of the mode here real quick. The mode can look in three different ways. Okay? The mode can look three different ways. Let's say I have the number set 1, 1, 2, 3. 1, 1, 2, 3. The mode is obviously 1. Okay. What if my number set was 1, 1, 2, 2, 3? 1, 1, 2, 2, 3. Well, the mode would be 1 and 2 because they're the equal amount, but they're also both the most. So 1 and 2. What if I had the number set 1, 2, 3, and 4, where nothing is there more often than anything else? And then that would be none or no mode. So you could have three potential different types of answers when you're looking at the mode. You can have your single individual specific numbers there more often than anything else. You can have multiple modes, like 2 or more, if they are there the same amount but more often than everything else. And then it is also possible to not have a specific mode. Okay, last but not least is the median. And I don't know, like throughout history, these things have always been presented to me as, oh, the three different types of averages, the mean, median, and mode. Mean, median, and mode. Mean, median, and mode. Nobody has ever messed up that order. Nobody says, oh yeah, the three different averages. You know, the mode, mean, median. It's almost hard for me to say. Or the median, mean, mode. Something like that. Nobody ever messes up the order when they say mean, median, and mode. Notice where the word median always comes. In the middle. And that's exactly what it's going to be. This is the middle number. Right, now, warning about this dude right here. What if I have a number set that is 1, 2, 3, 4, 5? Okay, first and foremost, the numbers have to be in order from small to big. Okay, you first have to order your numbers small to big. How do I find the median in this situation? Well, you start hacking equal numbers off of the sides. So 1, 1. 2, 2. And then you're going to isolate yourself down to a middle number. And the median in this case would be 3. All right. What happens if my number set is 1, 2, 3, 4, 5, 6? Well, in that situation, again, you do the same process. You start hacking away numbers. So 1, that's supposed to be blue, 1, 1, 2, 2. But now I can't eliminate another number because I wouldn't have any numbers left. So I can't eliminate the rest. So what do you do when your middle is isolated down to 2 numbers? Well, what you do is you take the midpoint. And if you recall from last chapter, what the midpoint is you add up the 2 different numbers and you divide by 2. So in this specific situation, that would be 3 plus 4 divided by 2. So that's 7 divided by 2, which is 3.5. Okay, so 3.5 would be the median. All right. I guess I'll talk about it just a little bit right now. Notice a quick way, like now it's all fine and dandy and easy peasy when you have 5 or 6 numbers in a list to find the middle. Like what's the middle? Well, it's just it's that number right there. But think about like when you have a number set that is substantially larger, kind of like what we have here in number 1. What would be the median if I just look at that set, or if I know what that list is? It'd be in your best interest to be able to kind of quickly identify it. So here, in this set right here, I had the number, okay, the number of elements, and so that number of elements is 5. All right, so if I want to split that in half, that is going to be 2.5. That implies that the middle number is going to be the third number. So if you go to element 1, 2, 3, it is the third number. So hypothetical is, what if there are 61 numbers, or excuse me, let me make that a little bit more difficult. What if there are 67 numbers in a list? 67 numbers in a list. What number would be the middle number if there's 67 numbers in a list? All right, so if I take 67 and divide it by 2, this implies that the 34th number would be the middle number. Okay, so I can just look, if they're in order, I can just look at the 34th number and be like, hey, that's the one right there. Okay, now what about when they're even, like the second list? Okay, in the second list, there were 6 numbers. Okay, there were 6 numbers. And so notice where the median is. It's going to be in between the third and the fourth number. Whatever the third and the fourth number are, that's going to be the median, whatever's in between the third and the fourth. So again, in a more difficult situation, what if there were 58 numbers in a list? Where would you look to find the median in that situation? Well, you divide by 2. And so what it's going to do, where you're going to look, is you're going to look in between the 29th and the 30th number. Whatever is in between the 29th and the 30th number. I'm not saying 29 and 30, I'm saying the 29th and the 30th number, whatever they happen to be. All right. So let's go to our list and figure this out. All right. The mean, you have to add them all up. Well, I'm not going to sit here and say 21 plus 21 plus 20. I'm not going to do that, homie. What I'm going to do is I'm going to use my calculator, because my calculator is able to do this pretty quickly. But the slow part about it is I have to enter it into the list. So again, where I went is I went to my menu, and I went to that stat. Again, if there's junk in there, delete all. All right, and so I have to physically enter these numbers. Okay, so I have there to be 40 numbers. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Cool, cool, cool. So I think I have all those numbers. I'll just quickly scan through them just to make sure I didn't make any obvious errors. Okay, cool, cool, cool. So I have the numbers entered into my calculator. So again, to find the mean, I have to add them all up. So what that means is I'm going to take the sum of that list and divide by the number of numbers. So I notice, just going to the bottom of my list here, okay, if you take a look at that side number right there, that indicates that there are 40 numbers in this list. There's 40 numbers in this list. So I have to add them all up. So I go back to my main calculator screen. I go to my main calculator screen and I add them up. So that would be the sum. Went to the catalog and I sum list 1. That's where I put them all. There is my mean. It's 26.25. Add them all up and divide by the number of numbers. All right, the median. All right, the median, what I'm going to do is, it's not quite equal to this, but this will help me out, is I take the number of numbers and divide by 2. So I see that it's an even number. And so when it's an even number, it's going to be in between 2 specific numbers. So it's going to be in between the 20th and the 21st number, whatever they are. So I have to find the middle of the 20th and the 21st number. So this implies that the 20th number, I'll go back to my calculator here, actually, and I'll look at the 20th number. So the 20th number is the number 25. The 21st number is 26. So between 25 and 26, so I go to my main calculator, 25 and 26 is 25.5. The mode, what number is there the most? This is just straight up kind of counting and looking. There isn't really a calculator trick to this. I'm thinking it's the number 25. So there's 2 of those, 4 of those, 4 of those, 3 of those, 1, 2, 5, 6, 7 of those, 7 of those. Yeah, nothing else is even close. 7, was it 7 25s? So 25 is what it is. Okay, it's there more often than anything else. All right. Now, letter D is probably something that we haven't done before. Letter D. it says find the mean with a 10% trim. 10% trim. What that means is this. If I have these numbers, and this list happens to be 40 numbers deep, okay, there's 40 numbers in this list, okay, and they're in order from small to big. Okay, what is a mean with a 10% trim? All right, so right now, our mean is what, 26.25. Okay, what it means is this. I'm going to take this, however, what I'm going to do, I trim off, I cut off 10% of the numbers, 10% of the numbers off the low and the high side. I cut off 10% of the numbers off the low and off the high. And then what I do is I find the mean of whatever's left. Okay, let's do it once and then I'll explain why. All right, so you take the 10% off the smallest and the biggest. So, actually, real quick before we get to the example. So if a 10% trim is cutting 10% off the low and off the high, what's the biggest trim possible? What is the biggest trim possible? The biggest trim possible would be 50%. Because if I take 50% off the low and 50% off the high, then I wouldn't be left with any list at all. All right? So you can't take a trim bigger than a 50%. That just doesn't make any sense. Otherwise, they're going to start overlapping. Okay, so 50% trim wouldn't leave you with any list at all. Okay. Here we go. So what I need to know is what is 10% of these numbers? How many numbers is that? And so I need to take 10% of the number of numbers. And so that is 10% of 40. So that's 4. So what I need to physically do is I need to cut off the 4 smallest numbers and the 4 largest numbers. So I would go to the smallest and I would cut 1, 2, 3, 4 of the smallest and 4 of the largest. Now, how do I do that in my calculator? Okay, so here we go. I go to my list where I keep everything. All right, and so what I do is I go to the very, very bottom. Okay, go to the very, very bottom, and I delete. I physically delete, which is, yeah, this button right here. I delete the 4 smallest. So 1, 2, 3, 4. Okay, I deleted the 4 smallest. I go to the top and I do the same. Delete 1, 2, 3, 4. Okay, so now my list is physically cut short 4 of the smallest and 4 of the largest off the bottom and top. Okay, so now I have that. And so now I need to add them up. So I physically did my trim. Now I need to add these numbers up. But before I do that, so I need to find the mean. And again, what that entails is I add up the numbers and I divide by the number of numbers. However, notice that if I had 40 numbers and I cut 4 of the smallest and 4 of the largest out of the list, like these no longer exist. Question is how many numbers do I have left? How many numbers am I taking the mean of now? And that should be, if I took 4 and 4, that would imply that there are 32 numbers left. So just take a quick glance. And notice how the total number is now 32. 32 is the grand number of numbers. Okay, so keep that in mind when you're finding your new mean. So I'll go back to my main calculator screen. I'll add them up. So I add up the numbers and divide by the number of numbers. Again, it's no longer 40, it is now 32 because I cut a grand total of 8 numbers off of it. So that is 831 divided by 32, and this comes out to be 25.98, 9688. All right. Oh, excuse me. Now, why the heck would you do that? Why the heck would you do that? What it does is, a lot of times there's weird numbers that exist in a number set. Like, so, think of a teacher that is really, really old, that is teaching. And I ask, hey, what's the average age of people in that classroom? What is the average age of people in that classroom? And so what that list would look like is you would have, you know, a bunch of teenagers. So the 16, 16, 16, 17, 17, 17, 18, 18, 18. And so if you take a look at this list, yeah, like, okay, you got all these teenagers, but then you have this really anciently old teacher. You have this, you know, dude that's like 93 years old. And so if I asked, hey, what's the average age of people in that class? The answer would be, you know, like 24 or something like that, you know, throwing the actual number off of what the intention of the question was. And so this number, for some reason, just, you know, it throws your averages off. It gives you unintended numbers. All right, so if there was just a way that you could kind of ignore that or take it out of the list, that's what you would want to do. And so this would be an example of when you would trim a list. Like if you had the ability to trim, like, you know, 2 numbers off each side or something like that, then the average of what's left is going to be, I wouldn't say it's not more accurate, but it's more towards the intent of the question, most likely. So when you're asked this question, why would you trim something? To eliminate the outliers. IERS, or YERS, something like that. I'll look it up. But it eliminates the outliers. It eliminates the outliers. And outliers are the extreme larges and the extreme smalls. Those are the outliers. So it eliminates the outliers. Okay, let's go ahead and do this one real quick. Again, you're asked the same questions, just a little bit different. So what we need to do is put these numbers in our list. All right. I noticed that there are 20 numbers in my list, so I begin by finding the mean. So I add up the numbers. And I divide by the number of numbers. All right, the median is the middle. Again, I noticed that I had 20 numbers. And so this is going to be in between the 10th and the 11th number. So in between the 10th and the 11th. So this comes out to be 71.5. The mode is the one that is there the most often. So I have 2 of these, 2 of these, 3 of those. I think that's it. Yep, the 3 60s. Does it in. Find a mean with a 5% trim. So I need to take 5% of the numbers, so that would be 0.05 times 20. And so 0.05 times 20 is 1. So what I'm physically doing is I'm going to eliminate 1 number off the small and 1 number off the big. So because these are in order, so what I'm going to be doing is I'm going to be deleting the number 45 right there. I'm going to be deleting the number 50. And so again, if there were 20 numbers and I took 1 and 1, that leaves a grand total of 18 numbers in this set. All right, so I go to my calculator, go to the very bottom, and I delete the very bottom number. Go to the very top, I delete the very top number, and again, to double check that there are 18 numbers. Yes, there are 18 numbers. And so now I go ahead and actually do my math. So I go to my main calculator, I add up all the numbers. Okay, and so this is going to be 2582 divided by 18. Because I deleted, oops, sorry. Spot. 2582 divided by 18. And that is my mean with a 5% trim. Why would we trim the mean? Yep. Okay, I spelled it correctly. Outlier. Why would we do it? To eliminate the outliers. Okay, the extreme larges and the extreme smalls. It does not make your answer more accurate. It does not make your answer more accurate. Write the short number set in which that would be trimmed to be useful, okay? So just write a short number set. My advice is when you're asked this question, write the example of the class that has a really old teacher. All right, so this would be something like 16, 16, 16, 16, 17, 17, 17, 17, 99. All right, with one weirdo number. Make it with one weirdo number. Don't make it with multiple weirdo numbers. People in the past have done number sets like this. Like, hey, write a number set that would be trimmed. And they go something like 1, 2, 40, 45, 99, 100. And they're like, oh, I want the average to be 40. And so they eliminate 2 of these things. And they say, okay, this is, but what my rebuttal on this is, if there's this many quote unquote weirdo numbers, then they're not weirdo numbers. Those aren't outliers. You know, that would imply that there's 33% of the numbers that are outliers. 33% of something is not weird. It's intended to be there. Okay? It's intended to be there. So don't make an extreme big and extreme small. Make all of the numbers in one single ballpark, and then just like one number that is weird. That's my advice to you on this. Make one weirdo number. Extreme large, extreme small, it doesn't really matter as long as there's just one, not multiple. Don't try to have it big and small, things like that. Just have like one large number and that's it. Okay, that is that. I'm sure I'll have to talk about it a little bit in other videos, but real quickly, what would happen if the numbers that you're given aren't already in the order that you want them in? Okay, let's say like I had crazy numbers and they weren't already big to small, right? They weren't already big to small. Let's just say, let's just say I had numbers, 6, 1, 4, 8. All right, 6, 1, 4, 8. And I needed to put those numbers in order. So what you can do is you can go to this. In your calculator, there's this thing called tool. Okay, and then there's this sort A. That means sort ascending. So sort getting bigger. So what I want to do is I want to sort ascend. How many lists? One list. Which list do you want to sort? I put everything in list 1, so it'll be list 1. And so what it does is it puts them in order from small to big. So if you're given like rando numbers in a number set and they're not already pre-ordered from small to big, again, where you can look is, okay, it's on these bottom options. You want this tool, sort ascending. And there it is. Okay. Yeah, get the assignment, and then we will talk about this again, I believe, again tomorrow. Have a good day, everybody. Keep smiling.